Alright, so the first thing we're going to do is do the moments or torque calculations to figure out the forces from the triangle there and the circle. Remember, the triangle goes both vertically and horizontally, and the circle just is going to go horizontally in this case. There should be a line here, I guess. Alright, so first thing we do is we're going to guess which direction the forces are going to go. So for A, the vertical force I think is going to be going up or down? Up. Up. So guess up. And we'll call that F-A-Y. What about the horizontal force, right or left? Or
It's going to be going right.
Left. I'm going with right. Right. Left.
Definitely right.
Right.
It's going
you're
left.
going to say left.
Well, we
Call it F-A-X. Alright,
Oh no, it's
if you guess wrong, you'll just get a negative value, and you know you have to switch the direction of the arrow on it. And what about at C? Right. And we'll just call that FCX. We could call it just FC as well, because there's only one force there. Alright, anybody remember the next step in finding the forces here is?
Force up equals force down.
so
Can't do that quite yet.
GC equals GC.
Torque clockwise equals torque counterclockwise. So the conditions for equilibrium are that our moments or torques clockwise have to equal the torques counterclockwise. Forces up. Actually, let's do it really like this. The summation of all the torques have to equal 0. Summation of all the forces in the x direction have to equal 0. And the summation of all the forces in the y direction have to equal 0. So if you look at the x direction, we have FAX and FCX. We don't know either of what those are. That makes sense. We can't use x. Y, we know what F1 is, and but we don't know what FAY is, so we could use FY, the summation of the force in the y direction, to solve for FAY. Do you guys want to do that first, or you want to do the torque thing first?
I want to do
let's do
I have torque written down.
Y first. Y first. It's quicker.
Okay, so we'll do the FY first. So we're going to say summation of all the forces in the y direction equals 0. Remember, up is positive, down is negative. So what is the, is FAY going to be positive or negative? Positive. Say it. Positive FAY and F1 positive or negative? Negative. Negative, so minus F1 equals 0. Yes, it is.
Why is it minus F1?
Because F1 is pointing down, and everything that is in the down direction is we're gonna make negative.
Right.
So FAY equal or minus 1,450 pounds equals 0. FAY equals 1,450 pounds. So I'll write that in up here. And it's positive, so do we need to change direction or anything like that?
No.
Nope. So that's the easy part. The beginning and the end are the easy parts. We'll get to the end in a while. Alright, so now we're going to have to use torques to find either FAX or FCX. What do we do before we use a torque equation, or the moment equation?
Choose your force time.
Choose your pivot point. What do we want to choose as our pivot point?
Triangle.
Triangle is usually the easier place because we get rid of 2 potential forces there. Alright, so we're going to say summation of all the torques add up to 0. Do we want to say the clockwise torques are positive or the counterclockwise torques are positive? Doesn't matter. Clockwise should be positive. That's fine. Alright, so is so what forces are causing torques here? F1, FCX. Does F1 go clockwise or counterclockwise? Clockwise. So we're gonna say positive torque from F1. What about FCX? Clockwise or counterclockwise? Counterclockwise. So it's gonna be minus the torque from FCX equals 0. How do we find the torque from F1? Garrett?
We multiply the perpendicular distance from F1 with the force X1.
Exactly. So we're gonna say F1 times the perpendicular distance, which I'll tell you what that is in a second, and then FCX times its distance equals 0. So F1 is 1450 pounds times its perpendicular distance from the pivot point. So we start at F1, we go only perpendicular to it toward the pivot point, and we get to here, and that's as close as we can get. So that is our perpendicular distance. That's the distance for F1. And so that, in this case, is going to be 11 feet. Any questions on that 11 feet right there? Why we use 11 feet? Okay. And we do minus FCX, which is what we're looking for, times what's FCX perpendicular distance to the pivot point? Y1, which is 9. That equals 0. So again, we go start here, just go perpendicular, and we get to the pivot point this time, and that's Y1 is 9 feet. So now we're going to say FCX times 9 feet equals 1450 times 11 feet.
$1772.2. I think.
That is correct. And that's 1772 pounds. Any questions on that part? Alright, our last step, we could either take our pivot point, move it to FCX to find FAX. It's probably a little more trouble than it's worth. What's our other way to do that?
Sum the F force and the X forces.
Sum the X forces. So we're going to say summation of the forces in the X direction equals 0. So remember, right is positive, left is negative. So is FCX going to be positive or negative here? Positive. So FCX. And is FAX, according to our assumption, is that positive or negative? Negative. So minus FAX, 0. So you get 1772.2 pounds. Minus FAX, 0. So FAX equals 1772.2 pounds. So those are our forces on those joints. I'm going to draw them in this diagram here. So FAX 1772, FCX is 1772. Any questions on that first part? You guys all feel like you could do this right now? Okay. Now what we're going to do is redraw each of these joints as kind of an individual piece. So I'm going to do that over here. Hopefully it'll make sense. So we're going to do another color. Alright. So this is going to be A. And we're going to have one going down like that, and that's going to be AB. One going down like that. I'm going to call that AC. we're gonna have force up like that, that's 1,450 pounds. Force going over like that, 1,772 pounds. We do the same thing down here. We've got, actually before I move on, why did I draw A and B both pointing away?
Because you assume it's intention.
We assume it's intention to begin with. So everything, when we start all these, everything's going to be pointing away from the joint to the point there. So now we're going to have this bottom corner, this is AC again, this side is BC, and we have 1,772 pounds pointing in like that. And then we do that corner right there. This is going to be BC. This is going to be AB. And then we've got 1,450 pounds going down like that. Okay, what are we missing to solve for any of this?
Angles.
Angles. Erase this conditions for equilibrium for a second. So we have this triangle. If we want to solve for this angle, we have these two sides. How can we do that? We have,
Tangent of said angle inverse.
let's call that theta. So we're going to have x1 is 11. That's 9. So this is going to be opposite over adjacent, which the next set is tangent. We're going to say tangent, that angle theta equals opposite 9 over adjacent 11. How do we get theta by itself?
Inverse tangent function.
Inverse tangent on both sides. So theta equals tangent -1 of 9 over 11. And what does theta equal?
39.3 degrees.
39.3 degrees. So that gives us this angle. How can we find that angle, since this is a right angle here?
90 minus 39.3.
So 90 minus 39.3, and that's 50.7 degrees. This is 50.7, this is 39.3, that's right angle again. Alright. Question on anything we just did? Alright. So now, we gotta pick one of those things to start at.
Mr. Tente,
Yes.
on the rightmost illustration is that angle 39.3.
Yes. Okay. So I'm gonna choose one to start at. There's actually, I'm gonna choose one that's a little harder than the easiest one to start at, because it's good for you guys to see how to do that, because there are going to be harder problems than this later on that you'll need to know how to do it this way. So we're going to start at this one. We're going to start at point A. It'll also make the last step really easy. Alright, so we're starting at point A, so we've got AB is going down like that. AC, 50.7 degrees, 1450, and 1772. Alright, so we're going to be using the summation of forces in the x direction equals 0, and the summation of forces in the y direction equals 0 on these. Which do you think we want to start with, x or y?
X.
We're going to start with x because we have In the y direction, we don't know AC. We also don't know the vertical component of AB. So it'd be ABY is what we're talking about. So we're going to start in the x direction. And remember, since AB is an angle, we break it down like this. That's ABY, ABX, and this is 50.7 degrees. Alright, so we're going to say summation of forces in the x direction, 0. What forces do we have in the x direction?
ABX.
So ABX is going to be positive because it's pointed right, and then somebody said negative 1772 pounds, and that's negative because it's going to the left. Well, we're looking for AB here, so how can we change ABX to have something with AB in it?
AB times the cosine of 50.7 degrees.
Sine,
So, oh, it is sine.
because it's opposite in this
Upside down.
case.
Yeah.
So it's going to be sine of
Upside down.
50.7 equals opposite, so ABX, over hypotenuse is AB. So when we solve that, ABX equals AB times sine 50.7 degrees. So now we take, since ABX equals that, we can take this and substitute in for ABX. So we get AB times sine 50.7 minus 1772 pounds equals 0. So we get AB ends up equaling 1772 pounds divided by sine 50.7. And what's AB equal?
2,289.9.
2,289.9 pounds. And is that tension or compression since it's positive? Tension.
Good job, Garrett.
And since it's positive, do we have to change around any arrows? Nope. Okay. Now we need to solve for AC. So I'm going to say summation of forces in the y direction equals 0. So we have force in the right direction. Is FAY going to be positive or negative?
Negative.
Positive. Is FAY pointing up or down?
Oh, positive. Oh, that was like X.
Sorry.
Way off to that.
So FAY. And then is AC going to be positive or negative?
Negative.
Negative AC. And is ABY going to be positive or negative?
Negative.
ABY is pointing down, so it's going to be negative. Okay, so FAY is 1450. AC is what we're looking for. And ABY, let's get that in terms of AB. Is ABY going to be sine or cosine?
Cosine.
Cosine, so we're going to say cosine Y over AB. And we get ABY equals AB times cosine 50.7. Plug that in over here. So we get AB times cosine 50.7. We get 1450 minus AC minus 2289.9 times cosine 0. 50.7 equals 0. So AC equals 1450 minus 2289.9 times cosine 50.7 equals 0. And what's AC equal?
-0.37. Oh yeah, 0.38.
0.38.
Or 0.37. Depends on if you round the 2289 or not.
Okay. Alright. That's pretty small, isn't it?
I got 0.
Paul got 0. Okay. Let's just remember that that was small, okay? And remember that Paul got 0. So we have AC and AB now. So we've got 3 of our sides of our triangle that we need. All we have left to do is find BC. To find BC, this is the easiest part. You're going to use this. So there are only 2 x direction forces here, right? So we're going to say summation of forces in the x direction equals 0. 1772 going to be positive or negative? Positive, so it's going to be 1772. BC going to be positive or negative?
Positive.
It's going to be, we're going to start with a positive here because it's pointing that way. So plus BC equals 0. So BC equals negative 1772 pounds. Is that tension or compression?
Compression.
Compression. And that means we need to switch BC's arrows since we got a negative number. So we should say BC equals 1772 pounds compression. Alright, let's look at AC again real quick here. How many forces are there in the y direction on this one?
Well, AC.
AC is the 1 force. So what does AC have to equal if all the forces in the y direction have to sum up to 0? 0. So we got a really small number for AC over there because of rounding, except for Paul, who probably kept all his decimals. So AC, when we look at this one, we know it has to equal 0. So these are the 3 answers I'd be looking for. BC is 1772 compression, AB is 2289.9 tension, and AC is 0. So it's not a tension or compression. Alright, do you guys have any questions? Quentin.
If it's 0, there's no tension or compression.
If there's 0, there's no tension or compression. Any other questions on this one? Charles?
Probably missing something. Why is BC acting in 2 different directions?
Well, we switched the arrows.
Yeah.
So all these are acting in 2 different directions. They're either like pulling toward the middle or spreading out.
I got it. That makes sense.
Claire, do you have a question?
Well, could like a diagonal one ever be 0?
It can be. I mean, if you like, you know, the MD solids thing you guys use. If you use that, you can't get zeros for those angles, especially if they're like being supported by something on the bottom. So it is possible. In this case, AB is never going to be 0 if it's like this. Kevin.
Okay, so I'm trying to understand this. BC was negative, so because it was compression because it was negative.
Yes.
So when you change that to being positive,
I changed being positive and switched the arrows.
oh, okay, all right.
Got it? Alright. Any other questions? Alright. The other problem here, which I'll scroll down to, it's going to be covered in ink here. Why don't you guys try doing, this one's on Schoology if you want to see it as well. Why don't you guys try doing this one on your own. Same problem with different numbers. So it's a good place to start. And you can stop that now.
Okay, I got it. So we're not gonna do that 13.